What's up, guys? It's Brandon Flash. Today we're at the Rivian Adventure Network site, or soon to be Rivian Adventure Network site. And I wanted to start off this video and we're going to talk about infrastructure and how different DC fast charger sites are actually configured and some of the infrastructure that goes into them. So like I said, this video we're going to be diving into some of the different components such as the utility transformer, switchgear, things like that actually make up these DC fast charging sites and some of the differences between some of the different providers and infrastructure installers. So we'll talk about Rivian, Tesla, Freewire, maybe a few others, and let's get to it. So as I mentioned, we're going to be talking about infrastructure, and this is a Rivian Adventure Network site, or soon to be a Rivian Adventure Network site. And I've actually had a chance to look at the permit application and full site drawings for this site because in many cases, those are actually public record documents. So over here, we have all the pads, and these are where the actual charger positions will go. And in this case, they're actually dispensers. So I think it's worth talking about kind of some of the different styles of charging infrastructure. You essentially have a couple different ways that you can do charging infrastructure. You can have it as an all-in-one system. So that means that the actual charger cable that goes to the vehicle and the actual power conversion where it's taking the AC power and converting it to DC are all in one unit. So you essentially have a conduit coming in with AC power, and then you're directly able to charge DC without any separate components. And that's actually how Rivian, Tesla, and Electrify America do it as of right now, is with dispenser and cabinet-based systems. But a lot of newer offerings are coming via all-in-one units, so Freewire and some of the others. So I think we'll start with where the power is actually coming into this site. So here we have the utility transformer, and in most cases, the utility transformer is owned and supplied by the power company in the local area. In this case, most likely Duke Energy. Yep, you can see right there, Duke Energy. And they're actually metering at the transformer because the meter is attached to the transformer. And looking at this, we have a 1000 kVA transformer. So kVA and kilowatt are not directly interchangeable, but for purposes of DC fast charging with a near 1.0 power factor, it's very closely interchangeable, but not directly interchangeable. Here we have the secondary voltage, 480. So that's actually 480, 277, three-phase. And the utility primary voltage is 14.4 kV, so 1000 volts. And this is taking that 14.4 thousand volts and stepping it down to 480, 277, three-phase. That power is then coming out of the utility transformer on the secondary side and going over here. So this is your distribution cabinet. And in this case, this site will actually have DC fast charging and AC level 2 charging. So we have a couple different things going on here. Over here, we have your main disconnect. So inside there is a 1600 amp, 100% rated, 480, 277, three-phase, 4-wire main circuit breaker. You then have a bus that's going from this cabinet into this cabinet. And in here you have most likely three. So you have 3 cabinet positions here, and you're going to have 3 600 amp, 480, 277, 80% rated branch circuit breakers. Additionally, you're going to have another branch circuit breaker of a smaller size, probably in the 50 amp range would be my guess. That's then going into this section that is a step-down transformer and 240 volt, 120 volt split phase distribution panel. And this is actually what's going to be supplying the level 2 units that are going to be installed at this site. So this is kind of a all-in-one site, and this is also what's necessary to install level 2 charging at a DC fast charger site, because you can't directly take the power coming off of this transformer and put it to a level 2 charger because it's not at the correct voltage. You actually have to step it down. So then coming out of this middle section with your 480, 277 branch circuit breakers, you actually have conduits that are going out the bottom here, and we're going to these 3 positions. I'll see if I have a photo from when the site was under construction, but Rivian uses bases for their charging cabinets that have the AC and DC labeled. So it's AC in, DC out. And each cabinet position can actually supply 3 dispenser positions. So this is a little bit of an interesting site. They're actually doing 2 cabinets initially and then having a reserved future position. So I'm not sure which one will be future versus initial, but these cabinets can actually supply 300 kilowatts total, and they can split it between the cabinets. Unlike Tesla, they do not have a DC bus between them. So if you happen to all go to the same cabinet linked dispensers, then you're going to be splitting power even though there's site power available, which is a bit silly. So these are your AC positions. They may be converted to DC in the future because this actually doesn't directly correlate to the plans that were submitted, so they must have done some sort of change for some reason. But the AC level 2 positions here are going to be fed from that third section there at 240 volt. So you'll have an AC charger unit there, they're waypoint units. And then over here, these are the pads for the DC dispensers. So out of the cabinets that are going to be mounted over there, you actually have DC power running into these conduits and then being dispensed out of the Rivian Adventure Network dispensers. So overall, I do think that Rivian's site architecture is pretty good. However, I think there is an opportunity for improvement with adding DC buses between the cabinets. That way, doesn't matter which dispenser you go to, they can all be on the same cabinet. But if you're able to share power between those cabinets, then you're still able to potentially get full power, because you don't need to have full nameplate capacity at the site, but you need to be able to use the connection as efficiently as possible. So now let's head over to a Tesla site that's actually basically across the parking lot, and it's a 12 stall version 3 Tesla Supercharger site. We'll also try and hit a version 2 Supercharger site so you can see the difference there, and then a Freewire site. So we've driven basically just across the parking lot. The Rivian site is just right over there. And this is a 12 stall version 3 Tesla Supercharger. You can see 12 stalls, of course, so they are actually using 1 dispenser per stall. And we actually have a pretty similar site architecture to what Rivian's doing. I think there may have been some overlap in who actually did the site architecture. Suspect that Rivian may have hired some of the former Tesla people. Here we have another 1000 kVA transformer, 14.4 kV input voltage on the primary side, 480 on the secondary side. We're metering at the pad mount transformer. We then actually have the same distribution panel supplier as what Rivian's using. So here we have a 1600 amp, 100% rated, 3-phase 4-wire, 480-277. And this is a little bit more compact version. We most likely have the main circuit breaker on this side, since this is on the transformer side, and then most likely the branch circuit breakers on the second side. Back here we have 3 Tesla version 3 supercharger cabinets. So here you can see that their max continuous current is 430 amps, and their maximum continuous power is 350 kVA. Which means that these cabinets are not 1 megawatt, which is contrary to what Tesla has stated publicly. But because they're able to have 575 kilowatt input of DC power, they can actually do 1 megawatt in theory, or very close to it, when it's sharing power between them, because Tesla is extremely smart in their system architecture here on the version 3 cabinets, and they actually have DC buses going between each of these cabinets. One of them is designated as the primary cabinet. They call that Star Center from what I've seen on their site designs, and that's the one that controls the entire site, and then they can actually share power between all 3 of these cabinets, and then that way it's outputted to the dispensers. And it doesn't matter which cabinet that the dispenser is actually directly connected to, because you can see here, so we have 2A, 2B, 2C, 2D. So those are all on cabinet number 2. But you could have 4 cars on these 4 positions, and you can actually pull power from the 3 cabinet or from the 4 cabinet, from the 3 cabinet or the 1 cabinet, and move that power across the site. It's actually extremely efficient use of that grid connection. with that 12 spots, because the likelihood of actually having every car filling here at a low state of charge able to take that full 250 kilowatts is near zero. And then on the dispensers themselves, so these are using liquid cooled cables. So you actually have a chiller down below at the bottom, and these are using precast bases that they ship into the site, and then that way they can set it a lot faster. You have extremely thin cables. These are liquid cooled, as I mentioned. This one's actually a bit damaged. Look at that. So I probably wouldn't use that myself, but you simply press that button that opens your charge port, plug in, you're charging in about 6 seconds, and they actually have their DC connections for the cable inside here. You just pop off the superficial cover and you can be replacing the cable with the liquid cooling system very quickly. Here we have a Model Y pulling up. So I must say that Tesla version 3 supercharger sites are essentially a masterclass in site architecture for DC fast charging. However, I do have some concerns that these sites will be able to keep up as Tesla charging curves or third-party vehicle charging curves demand more power for longer parts of the charging sessions, because these sites they're only averaging about 100 kilowatt per stall if you needed every stall in use, and that doesn't scale that well as technology continues to evolve. So I'm very curious to see how Tesla handles that, if they simply add additional cabinets maybe, but that's kind of where there's some risk to being so efficient that it's maybe not the most future-proof. But let's head to a Freewire site, which is a battery built-in system for DC fast charging, and then we'll continue on to a Tesla version 3 site, or sorry, Tesla version 2 site, and then to Electrify America, and I think that gives you a pretty broad representation of different systems. So now we're at the Highland Creek BP. We have a Freewire Boost 150. You can see there's not a lot going on here as far as things on the site. We have the unit itself. It's actually an all-in-one unit, has a 160 kilowatt hour battery built into it, and that's why it's so dang large. This actually does support dual output. We've got a BMW i3S, that's pretty cool. And this actually needs very little supporting infrastructure. So right here we actually have the main disconnect. So this is a 100 amp 240 volt AC disconnect. It's actually feeding off the store service, most likely the existing panel. We have some minor concrete work that was needed. And this unit actually came in to replace a previous EVgo 50 kilowatt, really old school unit. And it was a direct drop-in replacement just with some minor concrete work to support it, and saves a lot of space and infrastructure. So Freewire always likes to talk about how their units don't require any utility upgrades. They mitigate demand charges, things like that. I would say in a lot of cases that can be true. However, I would caution that if you're considering installing one, that won't be the case in every case, because you do still need about 27 kilowatts of grid capacity. You can do less technically, is my understanding. However, I generally wouldn't recommend it unless it's a very low utilization site, as that could actually cause some throughput issues and degraded customer experience. But for this particular use case, where it's replacing a previous 50 kilowatt EVgo installation, I think it's a pretty much perfect use case. You're getting essentially 3 times the output capacity, 150 kilowatt versus 50 kilowatt, because this is a Boost 150. They now actually have a Boost 200 that does 200 kilowatt. But you didn't need any utility infrastructure upgrade. And actually, the owner of this chain of BP franchises, you can see the BP canopy there, they have a bunch of EVgo sites, and my understanding is that all of them are being removed, likely due to site host agreements expiring would be my suspicion there, and they're all being replaced with these Boost 150s. And I think that's a huge upgrade. This one in particular is free to use, which is a little strange, and some of them have billing. Don't really know why that is, doesn't make sense, but that's not the topic of today's video. But you can see just how little infrastructure is needed for this Freewire unit to be installed, especially compared to the Electrify America that we'll check out and the EVgo that we'll check out. So let's continue on now that you've seen a Freewire. Well, you're now joining me at an Electrify America site, and this is actually an unusual site because it has 10 stalls. Most Electrify America sites are typically 4 stalls, some 6, some 8, some even larger than this. But I must say, 10 stalls is unusual, so grateful to have that in Charlotte. But let me give you a tour of the infrastructure here, and this is actually an ABB site. All of Electrify America's sites have pretty similar architecture. Aside from their brand new sites and the sites that they're retrofitting, those are a bit different than these. But this applies to all of their Gen 3-ish Signet, their older style, the newer style than that, but not the latest Signet sites, as well as ABB and BTC sites. So let me just show you here quick. So there you can see my Rivian actually plugged in, actually needed to charge a little bit. So here we have the utility transformer. So this one is actually a 1500 kVA, which makes sense given the site size here. So this is actually having a primary voltage of 7.2 kV and stepping down to 480, of course, and 1500 kVA there. This is also a Duke Energy site metered at the transformer, pretty typical in the Southeast. Here we have the distribution panel. So this is where the AC power is actually coming in from the utility transformer. So there's some conduits going underground here. And then out of the distribution panel here, which it's interesting that they label it as a charger ID with 00, we actually have all of these cabinets. And the way that these are set up is that you actually we have 6 over here and 6 over here, so we have 12. And the reason for that is these have a 1-to-1 relationship with the cabinets for 150 kilowatt units. However, for the 350 kilowatt units, they have a 2 cabinet for 1 dispenser ratio. So they're essentially linking 2 of these. I don't know which 2 are the 2 linked configurations here, but they also have future proofing down here so that they can upgrade 2 of the 150 kilowatt units to then be 350 kilowatt units. And fun fact, for ABB and Signet sites, 150 kilowatt units are actually 150 kilowatt units are actually 175 kilowatt units. But they label them 150 because the BTC sites are actually only 150 kilowatt sites, but they wanted to have consistency in naming across all of them. And then they go out to these dispensers. So this is a 350 kilowatt dispenser that I'm on here, for example. I was getting, still about 200 kilowatts there, so pretty good. So this, for example, is linked to 2 of those, whereas this one here, this 150 kilowatt unit, you can see that there, is only linked to 1 of those. So that's pretty typical Electrify America configuration. Well, we're now at the EVgo Tuckasegee location in Charlotte, North Carolina, and I just plugged in, we're charging. And let me give you a tour here. This is a site that's pretty indicative of what EVgo is doing for their new sites. They kind of have this as their latest generation with the 200 kilowatt city units and then a 350 kilowatt Delta unit, or sometimes Signet units. This one in particular is a Delta, but let me walk you through how they have this site configured. So as we've been doing, we'll start with the utility transformer here. So here we have a 750 kVA, 7.2 kV, 480 volt secondary side, pad mount metered, and I think this is actually slightly overkill for this site, given that we have 550 kVA of nameplate capacity, or 550 kilowatt I should say. We have 100, 350. However, the chances of this site actually being maxed out are near 0 because those 100 kilowatt units actually have 200 amp cables, and in reality it's pretty unlikely that all 4 positions will be in full capacity use here. Personally, if I was speccing this site, I would have specced it with a 500 kVA transformer, and I think that would be more than adequate, and I'd use some site level load management. If you haven't already, check out the Out of Spec podcast that I did talking about all sorts of different load management strategies for DC fast charging sites. So here we have the distribution cabinet. So we have power coming from the transformer over to here. And then interestingly enough, EVgo seems to be using additional disconnects. I really don't know why they do this. I know in some areas they can be required, but if they're not required, I would personally not install them, because I could just yank this, it would shut down that unit. I could do it on all 3, this entire site would be down and they'd have to roll a truck, and that would really just not be good. So we have one of these smaller ones for each one of these 100 kilowatt units. So these are 200 amp disconnects, and then over here we have a 600 amp disconnect for the 350 kilowatt unit. You can see that right there. And then we also have a step down transformer and a small I believe it's a 120/240 distribution panel. Let's see here. So we have primary volts 480, secondary 120/240. So this is only a 15 kVA step down transformer with a small distribution panel here as well. So that's actually supplying the auxiliary power for the dispenser, to my knowledge. Let's look at the nameplate here. You can hear the cooling system there. So we have AC input, so 120 volt AC input, so single phase. So this actually does need a small amount of just normal, essentially wall outlet power to run probably the display and things. Let's see how we're charging here. Getting the power there, 192 kilowatts. But after this disconnect, so we'll talk about the 350 kilowatt units here first. This is a cabinet-based system. So you have power going from the distribution cabinet over to here, the disconnect. So this is 600 amps. This is supplying the 480 volt. That's going to the cabinet here. And then you're getting DC out of this cabinet and 120 volt out of this step down transformer. And that's going to this cabinet here. And then that's what's actually supplying the power to the vehicle. And this can charge 2 vehicles at once. And we have the output here. So this will actually output 500 amps plus 200 amps. So if you had 2 vehicles charging here, one of them could get up to 500 amps, so like I'm getting right now. But if a second vehicle plugged in, they would only get up to 200 amps, which is really not ideal. I would like to see more dynamic split there, maybe 350, or just have maybe a 900 volt or 1000 volt connection to the dispenser, and then a buck converter to then step it down to the vehicle voltage and manage that in the dispenser. I think that would probably be a better strategy here. But let's talk about the 100 kilowatt units. So for those do, to my knowledge, do not need the 120 volt secondary input, but let's look at the nameplate to verify. So we have input, 3-phase neutral, ground, 129 amps, which is why we have the 200 amp disconnects, because you have to have it at least 125% of the nominal input. And we do not have a 120 volt input on these. So we are actually going from the distribution cabinet to the disconnect, one for each of these, and then that's going directly to these. And then we can output actually 2 different outputs at once. However, the site is configured that only 1 spot per unit essentially is in use. It's a little bit strange that they would have essentially 4 ports here, but only 2 spots. So I don't know why they do that. Probably because you don't really want to split 100 kilowatt. That's not a great customer experience. But also worth mentioning here that this site has built-in Tesla adapters. So these are essentially just a CHAdeMO to Tesla adapter attached to the side of the unit here. You can see it's literally just clamped onto normally the cable reel there. And then you have the CHAdeMO going in, just like that. And then that's where the CHAdeMO lives. They just attach that label there. It's literally 3D printed. Then you have the Tesla output there, and then that's considered kind of the primary output for CHAdeMO, and it's literally just the CHAdeMO adapter with a longer cable. But there we have it. That's an EVgo standard site, and if this was a Signet site for the 350 kilowatt aspect, you would actually have 2 cabinets and 2 dispensers. So it's essentially the same output result, maybe slightly better because those can actually do 500 amps on each, to my knowledge. But you'd have 2 cabinets, 2 dispensers, and each dispenser could only output once, but the cabinets would be 2 175 kilowatt units linked to then be a pool similar to this single cabinet that can do 350 kilowatts. So functionally very similar, but different architecture. And we have enough power here. Let's head to the Tesla Supercharger version 2 site. Well, the sun is starting to set, and we're now at a version 2 Tesla Supercharger site. This is a 12 stall as well, so very comparable to the version 3 that we were at previously. So you can see that there are 5 over here, and there are 7 over here, or at least they should be if my math is not failing me. Yep, we have 7 over here. This one's just kind of tucked back in. And here we have the 6 cabinets. So these are version 2 cabinets. This is actually something that was retrofitted. To my knowledge, that is the gateway that's also used for Tesla Powerwall. So we can see it here, charging gateway. So maybe it's just a modified version interesting input voltage range, 85 to 277 volts. That is a wild range. 30 watt power. And you can see that they actually retrofitted that down here. And they actually have these going to all the different cabinets. And if you're not familiar with Tesla version 2 superchargers, it's a 2 stall to 1 cabinet ratio. And these are actually older 135 kilowatt superchargers there. So you can see there, hopefully you can still hear me over the noise, 250 amp circuits, but they're 192 amp input current. And here we have the pad mount transformer. So this is a 1000 kVA pad mount transformer, 14.4 kV, 480 secondary. We have the distribution here. This is a 1200 amp. Most likely this is a 1200 amp, 100% rated main lug only configuration. And then we have 6 250 amp breakers or branch circuit breakers going to each one of these cabinets. This is also likely retrofitted. This is most likely a site controller. So some of this was not here when this site first opened in 2019 because Starlink, you can see up there, Dishy, did not exist in 2019. So most likely this was retrofitted so that they can have better status over the site and potentially for the use of third-party vehicles here, non-Teslas, because previously, to my knowledge, superchargers have been dependent on the vehicle connectivity in order to do everything, essentially. Even though they do have connectivity ports of sorts, most likely those were 3G only, and 3G has now been deprecated and is no longer in service at all. So that's why they had to do that retrofit. These are air-cooled cables, and they can do 330 amps continuous. And this is a pretty indicative site of a version 2 supercharger. Well, as you can see at this version 2 supercharger, basically Tesla's been doing the infrastructure better than anyone else for years. The site is 4-ish years old, and it's a lot more compact and actually overall higher throughput than a lot of Electrify America sites, with way less equipment, cleaner design, smaller distribution cabinet, and it just freaking works. Like, every stall here, as far as I can tell, is functional, and it's super compact and clean. It's just awesome. But anyway, I would love to hear what you guys think of these different site configurations, things that you'd like to see improved, things you saw that I maybe didn't call out that could be better, could be worse. Would love to hear your feedback in the comments. Anyway, thank you guys for watching. Hit the like button, hit the subscribe button. I'll see you on the next one.